Lesson 36 is right triangle congruency theorem, and it's just adding to our repertoire of things that we can use to prove things congruent. Okay, so this is specifically right triangle congruence. Okay, only works for right triangles. Okay, theorem 36.1 is leg angle. So along with angle, side, 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 angle, side, all of those things that you have to prove triangles congruent, we're now going to add LA, which is just leg angle. So make a little note, only works with right triangles. So this only works for right triangles. So leg and angle just means that you have to have another angle besides the 90-degree one. Okay, you don't get to count the 90-degree angle. It has to be a right triangle, and you have to have another angle and a leg that goes with it. So let's just jump into this. Example 1, we're going to be looking at the pictures in the book. So look at example 1, the picture in the book. Okay, this picture right here is the triangles that it's talking about. We're going to use, hopefully, leg angle because they just explained the leg angle to us. So notice that KL has one tick mark, and GH also has one tick mark. Therefore, LK and GH are congruent. Notice that angle G has one arc mark, and angle K has one arc mark, meaning the angle G and angle K are congruent. Also notice that they are both right triangles. So, ready, watch. This is the tough part. Here's a leg, there's an angle. Here's a leg, there's an angle. That's it. That's all you need. A leg and an angle to prove them congruent. So, use leg angle congruency theorem to prove triangle G, GHJ, and KLM are congruent. So I can do that by stating first a leg that is congruent. So example 1, I need to state legs that are congruent. I already told you what they were. It was side LK is congruent to GH. Sorry. LK and GH. Also, because of the one tick mark, we know that angle K is congruent to angle G. You should also notice that H and L are right triangles. Okay. You also need to know that angle H is equal to 90 degrees, which makes it right. And angle L is equal to 90 degrees, which makes those right. So by leg angle, we prove these two triangles congruent. So triangle GHJ is congruent to triangle KLM by leg angle. LA. So in whatever way that you're going to write this, whether it be a two-column proof, whether it be a whatever, okay, you have to state the things that are congruent, the leg and the angle. By leg angle. So for whatever way that you have to put it, make sure you state all of the things. You definitely have to have a leg, you have to have an angle, and you have to state that the two triangles are right triangles. So you have to state that their angles are equal to 90 degrees. Okay? Theorem 36.2 is hypotenuse angle. So hypotenuse angle uses the same kind of concept, except for we're going to look at the hypotenuse, not a leg this time. So again, zoom in. In this particular picture, the hypotenuse, being the one across from the 90-degree angle, is FD. And again, the one across from the 90-degree angle is GI. And they are congruent to each other. We also notice that angle D is congruent to angle G. Blam, the two triangles are congruent to each other. This is the statement that says that. So we just need to identify that in example 2. So on example 2, I'm going to say it out loud and then we'll write it down. To prove these two triangles congruent, we need a hypotenuse and an angle, or a leg and an angle. Since they already stated that PR and MO are congruent, and they are both hypotenuses.
So wait, you wouldn't have had that other angle for
The O?
Yeah.
O and R?
No, the P.
I need P because I have to have hypotenuse and angle.
You wouldn't have to have that, angle, you have the 90 degrees.
No, the 90 degree doesn't count. Remember, it has to be for a right triangle. So the 90 degree is the thing that says it's a right triangle. So we have to have another angle that is congruent. I'll explain why that is here in a little bit. Okay, so I need hypotenuse or a leg. So here it's a hypotenuse and an angle, P and M. So example 2, zoom out a bit. Example 2 gives us, like I just said, PR is congruent to MO. Okay, and we also know that angle M and angle P are congruent. Okay, other than that, I just need to state that the triangles have a right angle, that they are right triangles. So angle, the measure of angle Q is equal to 90 degrees, and the measure of angle N is equal to 90 degrees. So now I know that the triangles are right triangles, that I have a hypotenuse and I have an angle, so I can say that the two triangles are congruent to each other. So MNO triangle is congruent to triangle PQR by HA. Ha! Okay? They literally spell what you have to solve them. So intense. We're going to talk about one more, I think, and that will be, no, there's 2 more. Okay. On example 3, we're going to use Theorem 36.3. Okay, this one's called leg-leg, and I'll explain how these all go back together here in a second. But it's leg-leg, so LL. We're going to use LL to do this. And we're using the same concepts that we've been using. We need to search through the triangles to make sure that we satisfy some sort of theorem. So here's a leg that's congruent to that leg. This leg is congruent to that leg. So TR is congruent to LJ, and JK is congruent to SR. So I can say that the total triangle is congruent because they are right triangles and they satisfy that thing right there. Okay? So leg-leg. Here's the quick rundown of what it looks like if you wanted to look at it. Okay? We'll do it in shorthand version of basically the same thing. That's exactly what we've been doing, yeah. Just shorthand proofs. Okay, example 3, we go through, we look at the two triangles, we notice that TR is congruent to LJ, so we write it down. TR is congruent to LJ. A lot of you are still forgetting to write that bar on top of segments. Please do not. Very important. Then it's JK and SR. So JK is congruent to SR. So we have both of our legs. Now we need to state that they're right triangles. So angle J is equal to 90 degrees. The measure of it is. And the measure of angle R is also equal to 90 degrees. Okay? So we have two triangles. Both are right. And they have two sets of congruent sides. So we can use their names, JKL, and triangle JKL is congruent to triangle RST. It's not a very pretty congruency symbol. Questions?
Wait, that would be by LL.
By LL, yeah, leg. No questions. Okay, I'm going to go back. So flip your page back. I'm going to show you again this one right here. Now, some of you might have noticed this already, so I'm just going to re-point it out to you. This is the picture that is associated with hypotenuse angle. Notice this. Angle, angle, side. Did you notice that? Angle, angle, side is the same for any triangle, right? We can prove two triangles congruent by any two angles. So hypotenuse angle is really angle, angle, side. So let's start a little separate chart here. And let's say hypotenuse angle is really angle, angle, side. Okay? Hypotenuse angle is really angle, angle, side. something that we've already learned. Okay, I'm going to show you leg. So let's see what leg looks like. Ready? Side, angle, side. We've already learned that one as well. So it's nothing new. So leg is really side, angle, side. Nothing new there either. On this one is angle, side, angle. And this was really a picture for leg angle. So LA translates to ASA. Again, a thing that we've already learned. Okay, so I don't really expect you to use hypotenuse angle or leg or leg angle. There's nothing new. We've already used them. They're just reviewing them in terms of right triangle. So if you put angle side instead of HA, I'm going to accept it. If you put side angle side instead of LL, I'm going to accept it. Again, same thing for angle side angle instead of LA. Okay, any questions there? That's why I'm not spending a whole lot of time on this. We've already done it. Now this one is a little bit different, so I'm going to point out this one. And you'll figure out really quickly why we're not calling this one by its acronym and we're using hypotenuse leg. This one is angle side. Give you a little bit of time. Nobody. Okay. So we're not writing it down. So instead of angle side, we're going to use hypotenuse leg. So on example 4, we're going to do example 4. You should notice that these are both right triangles. Fairly obvious. The right triangle symbol is there. But then you will also need to notice that there is a hypotenuse and a leg marked congruent with a hypotenuse and a leg here. Okay? This is the only one that is different from any of the rest that we've already seen. This is the only one that's different. This is the only one specifically for right triangles. Okay? So on example 4, we need to state these things. First of all, we need to state they are right triangles. So I will state that angle U and angle Y, so the measures of angle U equal 90 degrees, and the measure of angle Y is equal to 90 degrees, which makes them right triangles. Okay. Next, I notice that WV is congruent to, because it has one tick mark, XZ. Next, you should notice that UV, because it has two tick marks, is congruent to YZ. Okay, so from that information, we can use hypotenuse leg to make the following statement: triangle UVW equals, or is congruent to, triangle YZX. If you ever get confused on how to write down the order of the triangles, just look at one of your congruency statements. Notice that UV is next to each other, UV is next to each other, YZ is next to each other, so YZ is next to each other. And you'll notice that X and Z are next to each other, X and Z are next to each other, Y, V are next to each other, Y and V are, or W, sorry, W and V are next to each other, W and V. Okay, there's your final congruency statement. Now most of these, you'll have to put in some kind of proof form, and you just got to practice those. Make sure that you're actually doing them so you can do them on a test. But every once in a while, I'm throwing in an application problem. So here we go. Example 5 and last example that you're going to see. Application of engineering. It says Rachel must design a plastic cover to fit exactly over the metal plate shown below. And again, that's a right triangle. The cover will contain a right angle. So Rachel knows that she only needs to pick 2 other dimensions to make sure that this cover is congruent to the plate. List all of the pairs of dimensions Rachel could use to ensure that the cover is exactly the same size and shape as the metal plate. For each of the dimensions, write which right triangle congruency theorem applies. Okay? So what do I have to match? And we're going to use this picture. So I'm going to say it out loud, and pretty much the answers are written below, so if you want to copy it, you can. Yes. Okay, so here, remembering all of the things that we've used so far, we've used, I'll just start at the very beginning, leg angle. So I need a leg and an angle to do this one. So I have 2 legs, so I can use either leg and either angle, but they have to be in order. So if I use this leg, I have to use angle P. So if I say PQ and let's say P, then that would be using leg angle. Okay? Or if I said QR and P, that would be again using leg angle. Okay? Also, I could say RQ and P, again using leg angle. There's 4 there because I can use this leg and that angle, or this leg and that angle. Again, I can use this leg and angle R or angle P, so I can use any of those. Okay, that's the first 4 listed on this solution, so if you want to look at them, you can. Next, I used hypotenuse angle, I do believe. Double check that. Hypotenuse angle is the next one. So hypotenuse, I only have one hypotenuse, but I can use either angle, so there should be 2 of those. So if I use PR, I can use angle P in combination with it, or I can use PR and angle R. And those are my only 2 choices, but I'll use hypotenuse angle for that. For leg, there's only 2 legs, so I only get really one choice here. I have PQ and QR. That's my only choice. I can't do anything else because there's only 2 legs that go together. Next, they had hypotenuse leg. So since I have one hypotenuse and 2 legs, I'll have 2 options. Hypotenuse leg, so I could use PR and PQ, or I could use PR and QR. That would be hypotenuse leg, either one of them. Okay, so you just got to be smart in listing those and write them down correctly. I know the book is different, but put a line over PQ. It's confusing you guys, and you're getting lots of easy points wrong. Okay, put a line over QR, over PR, over all that. Okay, they have to have a line. Questions, comments, concerns? Questions.